Hi everyone, it's Kathy Deeks, and this is the interactive case study on carbidopa, the medication that we are looking at and the mechanism of interaction. Let's see. Get to my next slide. There we go. Okay, so I just wanted to do a brief overview on Parkinson's disease because I lost a mentor, a physician friend of mine that I provided Pilates training to for several years as his Parkinson's disease progressed. And so Parkinson's is an abstract movement disorder. It occurs more frequently in men, but over the age of 60, it occurs at about the same rate as men and women. It's denoted by a dopamine deficiency, and like the picture suggests, it's a slowness and paucity of movement or abnormal excessive involuntary movements. 3 symptoms are used to verify it. 1 being a tumor on one side of the body when the person is at rest. 1 showing rigidity or resistance to movement, like involuntary slowing down or just stopping while walking. And a 3rd symptom is bradykinesia or slowness, like a masked face, a blank look on their face, and just not looking as though that they're connecting. And those are just all signs of dopamine depletion, because dopamine is needed for nerve cell communication. The carbidopa is a peripheral decarboxylase inhibitor, and it is one of the anti-Parkinson medications used to prolong the action of dopamine. It is unique in that it doesn't penetrate the blood-brain barrier, and it increases the availability of levodopa, and it binds to the PLP, which is the active site in vitamin B6. I'm just going to show a couple of seconds of this short video on what is the blood-brain barrier, so we can just review what that is, and then I'll speak more about it. Okay, so I just thought it was just a really nice kind of overview of some of the things that we're looking at in treating this disease, and why medication has to be so perfect and, have these extra features. The anti-Parkinson medication that we're looking for, such as the peripheral decarboxylase inhibitor, will inhibit its breakdown of dopamine and sensitize the dopamine receptors to stimulate the dopamine release. And so a peripheral decarboxylase inhibitor is going to bind to the PLP, which is the active form of the vitamin B6. And it's the enzyme that initiates the breakdown of levodopa, which is converted into dopamine, restoring the depleted dopamine levels. So carbidopa is this decarboxylase inhibitor, and levodopa, the combined medicine is what's typically used, and there's carbidopa is one of them, and then there's one other. And so it's unique in that it prevents the conversion of levodopa to dopamine by the enzyme aromatic L amino acid decarboxylase. And so next I'm going to show you an amazing picture of the technology. Just a second here if I can get this going. Here we go. So I have an amazing picture from this Chimera program that we're using, and I had trouble importing it into my PowerPoint slideshow, but I do have a picture of it here in the background, and I'm going to pull that up for you. It's utterly fascinating. So I have a little bit of more need to get familiar with my new Mac. So let me see if I can. Oh yeah, okay. I'm just remembering. Okay. Chimera, and then where's my picture? Oh, there it is. There it is. Yay. Okay, so I'm sorry, this is not like up and center on the screen. Well, actually, I think I can do that. Okay, and so here I made it this light green color just to stand out, is the PLP, the AADC enzyme. And so that is where the action takes place. And this is just, pointing out the size and angstroms and stuff. But this is the entire carbox. Oh, great. Now I just lost it. Takes a while to get used to all this stuff too, but anyways, I'm just rotating the molecule around here, and I think that's enough. I'm gonna pull it back up again, but I am gonna pull up my slideshow if I can find it. Okay, but anyways, I wanted to just show that amazing picture using that amazing technology. All right, so then we also are going to cover a little bit on X-ray crystallography, and we had done some review on this for a previous paper presentation this week. Sorry, I'm very, very tired. I did want to say one more thing about the mechanism of that enzyme, in that there is some new research, and I included this article in my references, looking at the gut microbiota that might be a mechanism for modifying the levodopa's bioavailability by expressing an enzyme that changes the levodopa into dopamine. And the study particularly goes on to study the serum AADC enzyme activity, which is increased in patients using levodopa along with a PDI, such as the peripheral decarboxylase inhibitor that we've been talking about. Okay, so the X-ray crystallography is one technique that's been around for a while of identifying the structure of a protein crystal. And so what it does is it works through this machine. We had this specialized protein crystal that has to be in perfect shape and form and stuff for this machine. And seen through the X-rays and projected onto film, people these days then could see what the structure of the protein was. Like, was it predominantly alpha helixes and beta sheets, or all the different components of the protein. And so the X-ray hits the beam, the X-ray beams hit the crystal, and then most beams pass straight through, but a few beams are scattered or diffused, and it's those diffused beams that will reinforce with each other and create dots that are then with more dots, you can observe a pattern, and that creates an electron density map. And they used algorithms, or it's all figured out now, but they would measure things like painfully the old-fashioned way and use algorithms and statistics to better define that protein structure. But I think most proteins have now been, protein crystals have been identified, and by their unique diffraction of beams or bending of lights that they do through the use of this machine. And then, this model here is, more we have available today. And like that one that I just showed you, that, the different colored ribbons can represent alpha helixes and beta sheets and all that kind of good stuff. So anyway, X-ray crystallography is unique. Thank you. Let's see how I end this. Oh my gosh.